Okay, the exercise 3 is about functions and conditions. So as you see, this function is defined from R to R for x less than 1, so is equal to x2. So for x between 1 and 5. Okay, so the first step is to import our library NumPy as MP. I'm gonna keep this cell for the just for the clarity. Okay, can't run it. I'm gonna add later on, since I will plot. I can from now import matplotlib. I can do it differently from. You have the two options from matplotlib. You can do it like this: matplotlib import pyplot as plt. This is okay. So the first step is to write a script for this function. So I would like to stress a detail. So this is my function. I'm gonna call it f, or instead I'm gonna call it ff. So as input you have x and x real. Okay. So this is your input x. Enter this function. So we will do an if. Okay. So if x less than 1, you're gonna do y equal to x2, and else if sorry, this is if the elif should start from elif x bigger, and then bigger or equal to 1, and x less than 5. This case, in this case, sorry, in this case, y, the output, I call it y, equal to 2x minus 1. Okay, and now if it is between, so else if, we come here, elif x bigger than 5 and x less or equal to 7. And here I should put it like this, less or equal to. So in this case, enter, you write y is equal to 7 minus x divided by 2 exponent 3. At the end, you write else. If you are not in all this, there is no need to else if x bigger than 7, you else y, sorry, else y is equal to 2. Sorry, means when it is bigger than 7, so is equal to 2. So, and at the end, now you should return, okay, you should return y. This is my, and just to be sure at 100%, we can try this function. So let's, for example, print uh, let's do it like this, y of minus 3, okay, and equal to dot format, and here f of minus 3. And for the others, let's do the same thing. We can create a loop for, we can do it. I don't want to complicate it for you. I'm going to do it like this. Okay, f of minus, between 1 and 7, I'm going to put the value 2. Here 2. Here you have 6. And for x bigger than 7, let's try 8. There, 8. So if you run all this, so y of minus 3 is equal to, since it is equal to 9. When y of 2 is between 1 and 5, so 2 cross 2, 4, minus 1, 3, so it is equal to 3. Y of minus 6, 7 minus 6 divided by 2, 3 exponent 3, 27 minus 7, you have minus 20. So it's okay. Same thing for the rest. So my function works well. It is just to verify. I don't need it. Okay. Now, what is demanded in the question number 2 is to draw f in this range with a step 0, 0, 1. I can take an x or a simple x, no problem. X or a double x, it's up to you how to define it. So NP, a range, for example, between minus 4 and 10 with a step 0, 0, 1. Okay. Okay. Minus 4, 10. I can define even like this. I can define it like this. Step equal to 0, 0, 1. Minus 4, 10. And I put step here. Okay. I can show you x. Imagine, for example, you take 0, 1. You obtain this. So minus 4, minus 3.9. This is when you have a step of 0, 1. Until you reach 9.9, but you never reach 10. So if you want to reach 10, you have to add here plus step. You will be sure that you will reach. Okay, like this, you reach 10. Okay, because he didn't take the last value, but he will take the value before, which is equal to 10 in this case. So this is the way. If you put step equal to 1, it works. So you find minus 4 until you reach 10. So I can print now, I can calculate y. Okay, this is x. I can calculate. Okay, after define the step, as I said, and the vector x, we will calculate y. And here there is something important we should stress it, that since x would take values between minus 4 and 10, so in this case you will have a certain number of f's, etc. So you should do it for every element in your vector. So for that, I'm gonna write, I have two ways to do it. The first way is to say that n is equal to length of x. If I print this, you will see that I have a vector x with a length of length of x, print n. This is my vector. I have 1401 elements, so I can write like this for n, for example, small n, in range n. I'm gonna calculate element by element. Okay, y n is equal to ff of x fin. Okay, so in this case, I'm gonna obtain a vector y, and then plt plt dot plot x, y, n. Do it like this. Okay, so like this, I obtain my curve. So I can now take a copy of all these elements here and make a small change. For example, here, x, my function f of x, y equal to f of x, y equal f of x. Okay, remove all these elements, keep only this one, like this. Okay. Okay, and run it again like this. Normally it's okay. The second way to do this is the following. I can change this. So instead of calculating the length of my vector x, I calculate it like this. I can remove all these elements, okay, and write that y, my vector y in reality is equal to, oops, my vector y is equal to, so I can create a list, but I will modify it to become a, so it's equal to ff of x for all small x for x in the vector x, xx. It means this operator means that in reality, you're gonna calculate for each element of this vector xx, each element, this one, okay? You're gonna calculate ff of x. You are creating a loop somewhere, okay? So when you do this, normally you get the same result, okay? Now this is your result. This is a function defined by interval, and maybe I prefer this. There's another way, uh, but it needs the modification of this function. Maybe when we can talk about this later on. Okay, we would like to modify this to be, I'm going to show you a second way to write this. This is the first way. The second way is to do the following. So I'm going to use the command in npwhere. So for that, I create a new cell. Okay, new cell here. Okay, so the idea of using npwhere, imagine I take a vector x, for example, let's say np uh, let's say in this range between 0 and 10 with a space of 1. So I'm going to print x, okay, print x. So if you run this, this is the vector x, and you can put it to 11, okay. So and y is defined as an NNP where x is less or equal to 4. I'm gonna calculate a value equal to let's say 2. And when x equal to bigger than strictly than 4, I'm gonna take minus 1. So in this case, you can print your x, huh? You can print your x here, your y, sorry. So the y is based on this. So as you see, until 4 you have 2, after 4 you have minus 1. Okay, so this is the idea. So I can now take an interval between 0, for example, and 10 with the space of 0, 1. And instead of doing this, I'm gonna plot. So I don't need to print. I'm gonna do plt dot plot xy. Okay, so this is when you use the function np where. So I can plot both of them. So like this, you will see if you are less than 4, it takes 2. If you are bigger than 4, you take -1. So I can generalize this. So instead of here where 2, I can put also inside this another condition. It means when it is bigger than, for example, np where x bigger, let's say bigger than or less than 7, I'm gonna take 8, otherwise I will take -1. So you need to understand what's going on. I need to also to close this parenthesis. So if x less than 4, I'm gonna take the value, let's say 2, okay? If it is not, if it is less than 4, you take 2. If it is bigger, you take this. And this is also conditional. It means that when x is less than 7 and also bigger than 4, you will take 8. Otherwise, you will take -1. So let's play with this. This is your curve. Okay. So this is how to do the calculation in this case. So my idea is to apply this in our case. Okay. So let's modify. Let's try something like this in our case here. Okay, instead of doing for like this explicitly. So we're gonna say that y here, I'm gonna delete all this and just I needed to. So I'm gonna say that y is equal to np where. So where x is less than 1, certainly I'm gonna take the value x exponent 2. Okay, otherwise I'm gonna do np dot where, and the condition in this case, x bigger than or equal to 1 and x less than 5. I can resume this, by the way, since here there's a comparison, I can put it np where x less or equal to 5 only. Okay, so np where x less than 5, I don't need even these parentheses, they are not mandatory in this case. I'm gonna take 2x minus 1. Otherwise, so the enter here, I'm coming to it is just for an organization. I can write all this in the same line, no problem. So now, if it is not less than 1, what is the adjoint is bigger than 1, bigger or equal to. And here it is bigger than 1 and less than 5. So I will take inside this condition strictly bigger than 5 and less than 7. So the second condition is np where x is less or so here, as you see, I would like to take between okay, for the first one it's okay until here. Now I would like to specify between 5 and 7. Between 5 and 7, I'm gonna take, so x less than 2x minus 1, x bigger than 7, bigger than 5, it is logic, and less than or equal to 7, I'm gonna take value equal to this one, I don't need to put end because I'm inside this where uh, because here it's already for x, yeah, in the second situation it's already bigger than 12. So here comma and the last value, so np where you take 2x minus 1, okay, or you take this value in this interval when it is less than 7, and in the other case you will take, I don't need to put other conditions, so for the rest you take 2. I'm gonna delete all this and try to see if it works. If it will not work, we're gonna modify it according to what is needed. So here, exponent 2 and p where there's a missing parenthesis in p where maybe there's a parenthesis here missing. Okay, so if you run it, I'm gonna delete this cell. Okay, so I'm gonna run this, and it works. No, it's okay. No, it's working. So it is easier to do it like this, but you need to understand how it works. And by the way, it is working like this because we didn't modify it here. Let's try to modify here now like this. So y equal to ff of x. And in this case, let's try to see if it works or not. Okay, it works. This is the idea. So I don't need to put a loop for here. This is the idea. The whole objective of this. It means that this function, even with condition, accepts directly a vector. This is the main idea and the main objective of the modification we made here.